In section 3 of chapter 5, we're going to take a logical step in the direction that we have been going. The last two lessons, we've been dealing with rational functions and multiplying and dividing them together. Only makes sense that we set up a section for adding and subtracting. And that's what this section's about. Now, the foundation of how we go about this process is relatively straightforward, and it's a straight line from what you did in elementary school to what we're doing today. The only difference is it's Algebra 2 level of difficulty, so it is a little bit of a challenge. But first, I want to review what we did back in the day when you were in elementary school / middle school. The way we do these problems, the way we approach them, the way we solve them, the way we finish them is going to be no different than what we're going to do in today's problem. So problem number 1, I have two fractions, 3 over 2 plus 4 over 5. I can't add them together because the denominators are different. In order to add them together, I need to get a common denominator. That is to say, I want to turn the 2 and the 5 through multiplication into the same number. The number that they can both turn into, the common denominator, is 10. I can turn the 2 into a 10 if I multiply it by 5. But I can't just multiply the bottom by 5, I have to also multiply the top by 5. For any of you that were ever curious why we can get away with doing this algebraically, it's because 5 over 5 is the number 1. I'm multiplying the 3 over 2 by the number 1. You multiply by the number 1, you're not changing its value. You're not changing its weight. You're just making it look a little different. That's why we can get away with doing it. The right fraction, the 4 over 5, I'm going to multiply that by 2 over 2. Same thing. I'm multiplying it by the number 1. So it's not changing its value. It's just changing the way it appears. So that'll give me a 15 over 10 plus 8 over 10. Now that the denominators are the same, we can add them together. You add the numerators. 15 plus 8 is 23. You do nothing to the denominator. And that's my answer. Problem 2 is the same thing, except it has a variable, it has an x. We don't do anything different. We look at the 2 and the 6. They both have a common denominator of 6, so I'm going to multiply this by 3 over 3. This first fraction has an x in it. This one does not, so I'm going to multiply the second fraction by x over x. That's going to give me negative 9 over 6x plus x over 6x. Now that the denominators are the same, I can combine them together to get negative 9 plus x over 6x. Or, that's the same thing as x minus 9 over 6x. Because they usually like our variables first. The way we approached those two fraction problems before is exactly how I'm going to approach this one. Problem number 1. I have a negative 4 divided by the quantity x plus 1 quantity times the quantity of x plus 5 quantity. Plus 2x divided by the quantity of x plus 1 quantity times the quantity of x minus 3 quantity. Notice, both fractions have an x plus 1 in common. But this first fraction has an x plus 5 that the second fraction is missing in the denominator. And this second fraction has an x minus 3 that the first fraction is missing in its denominator. So what I'm going to do is take the first fraction and multiply it by top and bottom, x minus 3. Second fraction, I'm going to multiply it by x plus 5 on the top and bottom. I can get away with doing that because if I multiply top and bottom of a fraction by x plus 5 over x plus 5, multiplying it by the number 1, I'm not changing its value, I'm just changing the way it looks. But that will allow all the denominators to be the same. Key point, do not multiply out the denominators. Keep the denominators factored. However, the numerators we do want to multiply out because we're eventually going to add them. So the denominators I'm going to keep the same. It's going to be x plus 1 times x plus 5 times x minus 3. The top I am going to multiply out. Negative 4 times x is negative 4x. Negative 4 times 3 is positive 12. And then we'll go plus x plus 1 times x plus 5 times x minus 3 all underneath. 2x times x is 2x squared. And then 2x times 5 is the 10x. We are going to be adding these two things together, which means we're going to take the numerators and find their like terms. We start with the highest power of x, which is 2x squared. There are no other x squares in the numerators, so we're just going to write 2x squared. We have a negative 4x, and we're adding a 10x. Negative 4x plus 10x is equal to positive 6x. And then we have a positive 12, and no constants over here, so it's just going to be plus 12. And here's the annoying part about these problems is I have to copy and paste the denominator. X plus 1 times x plus 5 times x minus 3. We're not done. You need to look at that numerator, the 2x squared plus 6x plus 12, and you need to factor that completely. Because who knows, maybe I factor the numerator and it cancels something in the denominator. I won't know until I factor. First thing, I'm going to use my favorite factoring technique. 2x squared plus 6x plus 12, all of them are divisible by 2, so I'm going to factor out a 2. And that'll give me x squared plus 3x plus 6, all divided by x plus 1 times x plus 5 times x minus 3. Now I got to look at the x squared plus 3x plus 6 and see if that factors. Spoiler alert, it doesn't. Therefore, the numerator is completely factored. Therefore, I am done. However, I just want to point out, let's imagine it was factorable. And it turned into 2 times x plus 6 times x plus 1 over x plus 1 times x plus 5 times x minus 3. The reason you need to factor is, let's imagine that numerator did factor into that what I have written in black right now. Since you have an x plus 1 on top and bottom, they would have eliminated. That's why you need to factor completely. Will that happen? Very rarely, but you still need to check on every problem. That's the thing that makes these annoying, is it is a lot of factoring. Hence why I said if you do not know how to factor, you really need to learn how to factor, because that is both the first step and the last step on a lot of these problems. Really the only thing that separates problem number 1 that I did in red with problem 2 I'm about to do in blue is problem 1, the denominator already came factored for us. Problem 2, if I want to combine those two fractions together, I got to get the same denominator. If I want the same denominator, that means the denominator should be factored. So first thing I got to do is that x squared minus 11x plus 30 on the bottom left, I got to factor that. You can use whatever factoring technique you want. At this point, you can go and start Googling factoring techniques. I don't care which technique you employ, but you need to learn how to factor this, and that factors into x minus 6 times x minus 5. The downside of the factoring technique I showed you and emphasized, which is the area model, is it takes up a lot of paper space. It takes up a lot of space on your paper. There are other techniques that take up less paper space. The downside of those is typically all those things that were written on paper, you have to hold them in your head. That's why I like the area model. You don't have to think about as many numbers constantly at all times. Downside is it just takes up a lot of space on your paper. Use whatever technique you're comfortable with. All right, now I have the x squared minus 4x minus 12. That factors into x minus 6 times x plus 2. Now this is why, I know some of you might be thinking, couldn't have I just multiplied this fraction by this on top and bottom? Yes, you can. But then you'd have to simplify it. And I'll tell you right now, when you get to that process where you have to simplify, you don't know all the factoring techniques yet. You won't be able to simplify it, which means it's technically not as simplified as it can be. You have to factor it before you try combining the fractions together or getting a common denominator, because they both share an x minus 6. I don't want to multiply this fraction by this. I just want to multiply it by x minus 5 on top and bottom. X minus 5, x minus 5. This I'm going to multiply by x plus 2, x plus 2. That's going to be equal to, the denominator is going to be x plus 2 times x minus 5 times x minus 6. For the numerators, x times 2x is 2x squared. 2 times 2x is going to be plus 4x. minus, denominator is going to be the same, x plus 2 times x minus 5 times x minus 6. For those that are wondering, like, why did I rearrange the denominators? I like writing them in a specific order so that if I later have to find something, it's easy for me to find. The way I write it is I always start with the positives, the one I'm adding, and I build up, so like plus 2, plus 3, plus 4, if that was there. And then I do the negatives and I do the same thing. Start with 5, then I did 6, if there was a 7, like x minus 7, I do that next. All right, multiply out the top right. 3x times x is 3x squared. 3x times negative 5 is negative 15x. 1 times x is positive 1x. And then 1 times negative 5 is negative 5. I'm going to save myself a little bit of space because I don't want to rewrite this all over again. What I'm about to do is I'm going to erase the negative 15x plus x, and I'm just going to combine those together as is to negative 14x. Just so I don't have to rewrite the entire thing all over again. All right, we are subtracting the second fraction. So that means we have 2x squared minus 3x squared. 2x squared minus 3x squared is negative x squared. Then we have 4x minus negative 14x. If you're subtracting a negative, you're really adding, so that's 4x plus 14x, which is 18x. And then lastly, we are subtracting a negative 5, which means we're really going to do plus 5. All over x plus 2 times x minus 5 times x minus 6. And now we need to factor the numerator, technically. However, this is the point where I want to pause. I wanted to show you with the red one why we should factor the numerator. We're trying to get stuff on top and bottom to eliminate, to cancel. I wanted to show you that that is a possibility. That is not what I actually want you to do. As soon as you combine these into one fraction, I want you to stop here. I think that's enough factoring for one problem. So you do not need to factor the numerator in this class. In future math classes, they might have you do that so that things could eliminate on top and bottom. I'm not worried about that right now. We'll do that going forward in the future. For right now, I'm mainly focusing on factor the denominators, get a common denominator, and add them together. At that point, you can stop.